solve the integral on screen. It may indeed be more simple than you think, and I'll explain why. So, if you do ever get a definite integral, and the upper and lower bounds of this integral are simply negatives of each other. In other words, given a graph, the upper bound at some value, if you were to multiply it by -1, it would give you a point over there. So assuming that those 2 points, which are equidistant from the y-axis, assuming those are your upper and your lower bounds, then it's important to check if your integral is an odd function. Because if your integral is an odd function, or what's inside your integral is an odd function, then it turns out that you'll be adding an area to the left of the y-axis and subtracting it to the right of the y-axis, or vice versa. So I'll give you an example that's easy to understand, and that's the sine of x graph. The sine of x graph looks something like this, where this area between 0 and pi is the same as the area between 0 and negative pi. So if we were to calculate the area of sine of x from negative pi to pi, we would be adding this negative area and then adding this positive area. And when you are adding a negative to a positive, you're subtracting it. So that subtracted by that will give you 0. So it's equal to 0. So the first thing we're going to do when we notice that our bounds are simply the negatives of each other, the first thing we're going to do is test whether our function within our integral is an odd function. So what does it mean for a function to be an odd function? If we were given the function f of x, and we were to substitute in negative x into this function, it would be odd if our output was a negative f of x. So let's try that with this expression over here. So substituting in negative x into x to the power of 4, we get negative x to the power of 4 times by e, so the negative x to the power of 2 times by sine of negative x, all over negative x squared plus 1. Okay, so what does this simplify to? Negative x to the power of 4, it's raised to an even power, so this will become positive, and we'll simply get x to the power of 4. Then negative x raised to another even power of 2, it'll become positive again, so we'll have e to the x squared. And then sine of negative x, we know sine is an odd function, so that'll give us times by negative sine of x. And then when we raise negative x to an even power, it becomes positive x squared plus 1. And then we can take out this negative. And there we go. So if we defined this original function to be f of x, then we substituted in negative x. Then this is indeed f of negative x. But you'll notice here that this function is simply negative f of x, because this is exactly the same to our original function. So it must then mean that f of negative x is equal to negative f of x. And therefore, we have an odd function, and this integral, without needing to do all the fancy techniques of integration to make this simpler, we can simply state with confidence that this integral, this definite integral, is equal to 0.